Yeah, hello, good friends. Always here. I hope you're doing well wherever you are. I'm also doing okay. Good to have you back, right? Yeah. Today we want to speak of a very simple but interesting topic, which is called bracings. Because bracings is something. If you want to major in structural engineering, then maybe nearly all the times you'll be meeting bracings, because if you go to steel structures, you have bracings, if you go to concrete structures, we also have bracings there, right? So it is very important to understand the basics behind bracings, so that it never intimidates you anymore, right? So just keep it here. What exactly are bracings? That is the first question which I think is coming to your mind, right? What are they? Well, let me just do a sketch to show you what bracings are. I'm sure you've ever seen, maybe say this one is a frame, a steel frame, yeah, and maybe it is supported here. There's a pin support, and this is also a pin support. I'm sure you've ever seen, let me use a different color for that. I'm sure you've ever seen these diagonal members which runs from corner to corner, right? Yeah, so from this corner to corner, you've ever seen that member. Then also this, same to here, So for steel structures, these are what we call bracings, So we have both vertical bracings and we have horizontal bracings, but then today I want to just speak of vertical bracings. I will do another video so that we can explain, we can interrogate how exactly the horizontal bracings work. They're called horizontal bracings or plant bracings, right? Yeah, so this one is for steel structures. What about concrete structures? Look, if you have say you have your columns. Maybe you have your columns and you just have a frame, maybe a concrete. You have a frame. Frame is simply made of columns, beams, Yeah, so perhaps maybe you have these are your beams here. These are your columns. So this is a frame. This is a concrete frame. This is a concrete frame. And you have your supports, maybe going to the foundation, right? You have your supports. So bracings in concrete structures is usually just a shear wall, where you find a very big concrete wall running from the foundation. Let me do another color for that. You find a concrete wall called shear wall running from the foundation, and it is going all the way up, right? Yeah, so this is the shear wall. This one is a shear wall. So in concrete structures, this is the bracing. This is the bracing in concrete structures, right? Because it is the one taking care of the lateral loads. What I mean by bracings, you can see the picture here. We have different kinds of bracings. We have the V bracings, just from you can see it. This one emulates the letter V, that is why it is called a V bracing, and this one is inverted V, it just deriving the name from that. This one is diagonal bracing, this one is X bracing. X bracing is the double one, and also the K bracing. From the letter K, we have this one. That is the K bracing. And for the shear wall, this one here, as you can see, is the shear wall. Let me just this one here. This one here is the shear wall, Yeah, so this is what they are in reality. So I hope you understand that better. As to the second question, the first question was what are these bracings? I've answered that. I've drawn the sketch of these bracings, both in steel structures and also in concrete structures, right? But then, why do we need these bracings? Yeah. Well, before I answer the question why do we need these bracings, perhaps it is good I speak about one thing here about moment connection and also a pin connection. So if you have a connection, say for example this connection here, this is a pin connection. What do we mean by pin connection? Pin connection is a connection which does not transfer moments, right? Yeah, it is a connection that only resists movement in the lateral and vertical direction, but does not resist rotation. You get that? Yeah, so this one is easy to do. The importance of a pin connection is that it is easy to do. You can do it quickly on site, and also you don't require a lot of time to do it, right? That means, of course, you don't require a lot of resources to that pin connection, right? Perhaps I'll do also another video to explain in detail pin connections and moment connections. But then pin connections, you don't require a lot of resources in terms of labor, in terms of time, and also in terms of materials, right? But if you come to moment connection is a connection which resists moments. That means, maybe an example, you have a connection here. Say it is a moment connection. This means this connection will transfer moments. What do I mean by that? This connection resists bending. So this member here, even if you apply a lateral load, say at this point we apply a lateral load here, then this member, this point, will resist that bending. But if it is this pinned connection, if it is this pinned connection, then it will not resist bending. What will happen is that this member will simply collapse like this. This member will simply collapse if we have a pin connection. But if you have a moment connection, then this member will just remain still. This member will not collapse. Maybe there will just be some very little deflection, because it cannot be zero. In reality, in academia, it is zero. But then in reality, deflection cannot be zero. But then it will be very minimal. Deflection there will be very negligible, right? Yeah. So that is the difference between a pin connection and a moment connection. So moment connection is very costly. In terms of economy, it is very expensive. It requires skilled labor. Somebody who can do moment connection very well. It requires expertise. Also, it takes a lot of time, right? So mostly engineers do prefer just doing a pin connection. Then after doing pin connection, they do bracings. So bracings are taking care of the lateral loads. Even if you come to concrete structures, this shear wall here will be acting as what? As bracing. It will be taking the lateral loads, so that even if you apply a lateral load at this point, say you apply a lateral load at this point, then if you have this shear wall, then that means this member will be so rigid. Shear wall, the rigidity of a shear wall is to infinity. That means it is too rigid, compared to columns. Why is it too rigid? Because it is very deep. Take an example of a deep cantilever beam. So a deep column, this member here is so deep in this direction. This member is so deep in this direction. Let me just show you. This is the direction. This member is so deep. So it will be so good in resisting rotation. It will easily resist moments. Because it is so deep. That is why engineers will prefer it. So we just have a pin connection. Then after having pin connection, we make sure that we provide a shear wall in concrete structures to take care of the lateral loads, like the wind loads, or the earthquake loads. So that is entirely the point of having bracings. How really do load, what is the load transfer mechanism in these bracings? Well, for steel structure like this one here, well, if you apply a load at this point, then obviously it will set this member up here into compression. This member will be under compression, because this load will be traveling through this member. Then if it reaches here, it will be resisted by this member. You see this member here, this member will be in tension. This member will be in tension to resist that lateral load, right? Then after that, that load will be now taken by this member, which will transfer it to the foundation. Very interesting. Load comes from here, travels through this, and will be resisted by this, which will be in tension, and at this point, this load will just travel to the foundation. So if you're designing this member here, make sure that it can take this load, right? But it is good to do your analysis. Maybe you can do analysis, can use the methods of joints, can use a method of section, to get the loads in all these members. Because, well, when this load acts here, it is not only this member which will be carrying that load. This member here will also be set into compression. This member will be under compression, but you have to know what is the load here. But then this will be in compression, this will be in compression, but this one will be set into tension. This one here will be set into tension. This one will be set into tension. So you have to design this member here to be adequate in tension, so that it can carry tensile, that force. But then this member should be able to carry that compressive load. Otherwise, it will buckle. It will simply buckle. Even this member here should be able to carry the compressive load. Otherwise, it is simply buckle. Buckling is just something like that. If it can't carry that load, then it will simply buckle. So basically, that is the idea. Of course, this member also will be in tension. Well, take an example. You just pull this, you push this one will be experiencing tension. This one will be experiencing compression, this one will be experiencing compression. Then if this load reaches at this point, it will also be setting this member into what? Into tension. So that is the point. Then if it reaches here, this member will transfer it to the foundation. Well, if we apply that load, maybe at this point, this member will be in compression. This member will be in compression. It will also set this member into tension. This member here will be set into tension. Of course, this member will also be in compression. So you just have to do your analysis and see your forces, and see your forces, so that you design your members for the right forces, right? So basically, that is the idea behind bracings. If you come to maybe concrete structures, if you apply this load here, obviously this load will travel through here, and then it will be taken by this deep shear wall. If you put this load here, it will travel through this member, but then it will be taken by this deep shear wall. Okay, same to this, it will travel through this member, it will be taken by this deep shear wall. So actually, the idea of having bracings is that they are very efficient in taking the lateral loads, as compared to moment connections. Moment connections, are very expensive to do, and of course will take time. So you should be good in designing these bracings, because maybe in one of your projects you'll meet one which requires that you design the bracings. Even if you do a water tank, you have to provide bracings. Yeah, water tank, you have to provide bracings. If you can't do moment connection, I'm sure you've seen a water tank or a electricity transmission tower. Yeah, you've seen tower having so many bracings. Those are meant to transfer just the lateral load. Okay, and it should not intimidate you in any way. So I intend to really stop here. I really love interacting, and so if you have any questions which you think that I should respond to, I'll highly appreciate that. Right? Just put them in the comment section. Tell me what you really need to know, or what I really need to explain further, and I will really appreciate that. Otherwise, let's know bracings intimidate you. Once again, I'm interested in explaining the basics so that when you go to design, I find it quite easy, because if you go to design before you understand these basics of how they work, then you'll have some uphill task. Okay, yeah, so to avoid that, just make sure you really understand the idea of bracings. I intend to stop here now. Thank you so much. If you haven't subscribed, kindly hit the like button, and also make sure you subscribe to this video